Okay, so we're going to continue part B of part 2 of grade 5 of Show Your Work, Hardest Math Problems. So I am just going to jump right into it, just to make sure this is all set up. Yes, it appears to be. So what I'm going to do is going to split this into 3 parts. We did the first part, part A. This is going to be part B. I'm going to use 2 examples that involve volume. And then I think there's 3 other problems I'll split into a part C. Okay, that way I can use this as an exemplar for some of these as well. All right, so let's jump into here. Let me see, my tablet's going. Yes, it is. So we have a 5 by 3 by 2. We're going to look at the illustration first. Rectangular prism. We can do quick math. 5 times 3 is 15 times 2 is 30. So we have the volume here is 30 cubic feet. Okay, FT with little 3 up there. You could also write it like this, cubic feet down there. Okay, there's really nothing else that they're throwing at us here, so it's hard to really grasp kind of what to think about it. I often tell you guys to look at the illustration because sometimes you can start grokking what's going on through it, but here there's not really much of a bone they're throwing towards us. So let's go to the words. A toy company uses the box shown below to package wooden cubes. So inside of here is going to be going wooden cubes. So I could just kind of draw one because I don't know, they're not giving us enough deets yet about what the cubes are looking for, but there's a cube in there, not too nicely drawn, and that was 30 by the way, and that's a V, volume equals, my handwriting is just lovely, isn't it? So for starters, now we're going to come down to here. Each wooden cube has a volume of 1/8 of a cubic foot. Okay, so there's a whole bunch of cubes in here, and each is 1/8. How many wooden cubes would fit? So if we keep stacking the cubes everywhere so that they fill up this way and this way, they fill that way and that way, and they fill this way and this way, right? Every dimension is going to have these cubes, and hopefully, by the virtue of the question being worded this way, there's no extra space. There could be extra space, right? Because it could be like when we get up to a corner, let's say a whole bunch fit right here, and there's a little tiny space there. So we don't know that really yet, all right? So what we want to do is to be able to kind of sit down for a second and analyze this a bit and just kind of see what kind of should the operation be that's happening, right? What's supposed to be happening here is really what the question is. So it seems to me that if the cube itself, if the cube is 1/8 of a cubic foot, okay, and the total volume, right, this is the volume of the cube, the wooden cube, and the total volume of the box is 30. It seems to me we need to divide that, right? So for argument's sake, if the cube was 1 cubic foot, wouldn't that mean 30 could fit in the same space? Maybe not whole, but certainly smashed up altogether. Remember, the cube is solid, it has no rounded edges, and if it packs up against each other. So if a cube was 1 cubic foot, the wooden cube we're talking about, if the wooden cubes are 1 cubic foot, and the whole volume of the whole box was 30 cubic feet, seems to me we should be able to somehow, including destroying the wooden cubes, fit 30 of them. So basically what we did was 30 divided by 1. So we have the volume of the box divided by the volume of the cube. So we just need to do that same thing then. So if it's the volume of the box divided by the volume of the cube, what we have is 30, and it's cubic feet divided by 1/8, and that's also cubic feet, so we have no unit problem here. Let's make that 8 there. And then we just have to do that division. So it's often handy to map this into this, 30 divided by 1/8 right there. Okay? And then we know that division by a fraction is the same as multiplication by its reciprocal. So this part here becomes times 8/1. Okay, and then we get the 30 stays the same, and then we end up with 240. Okay, so 240 of these little wooden cubes can fit inside of there. Just let's make sure that it's looking for cubes. Yep, wooden cubes is the unit it's looking for. So that's a weak kind of double check that we at least got the units right that we're solving for. And there's really no part 2 to this question, which is kind of cool. Sometimes it's hard for students to tell if there's extra steps or anything involved here. Nope, it's just the volume divided by each piece there. That's one way to have done this. Another way to do this, and this gets a little more cryptic, which is why I kind of postponed using it, which is that if the wooden cube, and let me draw one of them again a little more neatly. If it's a cube, that means this length of this side is S, the length of this side is S, and the length of this side is S. They're all the same thing. So to get the volume of this cube, I'm going to do S cubed. Okay, that's how I normally get it. Okay, they're telling us that that volume is already 1/8 of something. So remember, S cubed means S times S times S. So what we need to do is, if S cubed is equal to 1/8, we need to get the cube root. I'm going to put a little 3 there and a little 3 there. We need to get the cube root of both sides. So the cube root of S cubed is S. Now the question is, what's the cube root of 1/8? In other words, what times what times what equals 1/8? It turns out that that's 1/2. Right? 1/2 times 1/2 is a quarter, times 1/2 is an eighth. So it turns out the side length is a half. So the cube root of an eighth is a half. Okay? Because what some students do is, instead of doing it the original way I solved it, they're going to take, for instance, this 5. They're going to take that 5 and divide that by an eighth. Okay? And that's going to equal to 40. Okay? That's no good, because what they're trying to do is stack the cubes along the bottom here. But the side length is not an eighth. The side length is a half. The side length is a half. Okay? So that means what we should be having is 5 divided by a half equals 10. That means 10 cubes can fit along here. And we can do the same thing with the other one, with the 3. 3 divided by a half is equal to 6. Right? And then the 2 divided by a half is equal to 4. So those are the 3 numbers, the 6, the 10, and the 4. If we multiply that, we get 60 times 4 is 240. That's the same number we got earlier. Okay, so that's another way to solve this, by visualizing the pieces. That's still math. The other one was pure math, by getting the expression with the volume of the box divided by the volume of each wooden cube. But this also works, right? And we can double check that. If there's a half here and we stack them up, yeah, we're going to get 6 there. And if we go along here, we're going to get 4 up and down, right? If each is half a foot, not half an inch, half a foot, right? Because it's cubic feet. So the original started as 1/8 of a cubic foot. So the length of a side is half of a foot, right? So we can easily see if it's half a foot, that 10 can go across the 5, 6 can go across the 3, and 4 can go up and down across that, right? And if we multiply them all out, we get 240. All right? So be careful with that. So this is a geometry question, obviously involving volume and involving fractions of volumes, though. So that's kind of the gotcha-ish thing here that a lot of you guys need to be concerned about. Some students think this 30 is the answer. 30 alone is not the answer. That's not what they're looking for. Okay? Some of you also do 30 divided by 8 and get what? 3, 24, 6 eighths, 3 and 6 eighths, which becomes 3 3/4. That's not it. Remember, do your little experiment on the side first, like I did over here, to try to figure out what makes sense here. What actually is the algorithm that you need to decide this? You know, logically go through it and figure it out, okay? So this is really about fractions and volume. And this one here is a good way to approach it. It's your double check. It's an alternate way of doing it. All right? That once you realize that, and by the way, some of the students too, instead of, they can get so far as realizing there's a cube root here, but something goes awry, and they end up thinking it's a quarter instead of a half. So once you get a quarter, you're going to get the wrong numbers on the other parts as well. All right? So be careful with these things. And we can also see it. This is also about division by a fraction. So you use the multiplication by its reciprocal. We keep seeing these for the grade 3, grade 4, now grade 5. This is a repeating thing. Students are still making that error. They haven't still quite figured that out, that that's the rule you need to know. And if you didn't know it before, now you know it now, right? So guys need to just stay being careful with these kind of things, all right? So the next one we're going to do, I think, was the last question. It's a similar question. And then we'll end this, and I'll do a part C either right after this or tomorrow or something, depending on what's what. So remember, these rules are all here. It's about using them. All right, here we go. Let me see, there's a part B to that? No. But I do notice the answer has to be in boxes of Lucian. So let's see what they're talking about. So there's two illustrations. This cube here. And this cube right there, that cute little cube down there. So we can kind of do the same thing. And by the way, the other one was a rectangular prism. This is a cube because it's a 2 by 2 by 2. So we know that's going on there. Okay? So its volume is basically 2 cubed, or 8 feet cubed. Okay? This cube down here is 3 times 3 times 9. 3 times. Bleh. I mean, its volume is 3 cubed, which is 27. However, it's in inches. It's not in feet. Okay? So probably we have another scenario where we have to do a unit conversion. Okay? And they're probably going to have us do the same thing. How many of these can fit inside of that? Okay? So we either have to convert, if that's the case, we have to either convert the 8 feet cubed to inches, or the 27 inches cubed to feet. Okay, and both ways can work if that's what they're asking us to do. So let's go back to the words. A company puts bottles of lotion into boxes that are 3-inch cubes. So there's lotion inside of these. These are the boxes of lotion. They were, and then put, instead of a big box, they're calling it a crate. So the large cube is a crate. And this is lotion down here. So we're doing that to make sure we're keeping track on what's what. Okay. So that's and how many boxes can fit in there. So it does turn out to be that that's pretty much the same question as the other one. So we do have to do a conversion. So first of all, you should know that 12 inches is 1 foot. Therefore, 2 feet is 24 inches. So an alternative volume for the cube is 24 cubed. Okay? So we can go along the side and figure that out. We're going to do 24 times 24. 4 times 4 is 16. Carry the 1. 4 times 2 is 8, plus 1 is 9. 4 times 2 is 8. 2 times 2 is 4. Okay, 6, 8, 16, 7, 1. We get 576 times the next 24 still. Okay, so we have to do that on top of this as well. So let me try to write this as neatly as possible so I don't mess it up. 576, was that the number? Yes, times 24. I have dyslexia, so I don't always see numbers properly. And I always have to double check them 1,000 times. It may not seem that I'm doing that all the time, but I have to. There's no choice. Anyway, 6 times 4 is 24. And by the way, this is how I do two-digit multiplication. I know some of you other guys have learned different ways. I explored some of those ways in a couple of videos ago, maybe in the grade 4. However you can do this is cool. Personally, I think this is one of the most efficient ways to do it and the least error-prone. Some of the others get too much writing down numbers, too much adding, all these kind of things like that. And what we often try to want to do is keep our numbers less than 100, basically the 10 by 10 multiplication table. And this kind of does that, including when we're adding stuff up. All right, so some of you guys, for something like this, you're going to come up with about 10 multiplications and 10 additions. It gets too much. And it's all across your page, scattered about. And sometimes you forget to add something in. Sometimes you leave something out. To me personally, it gets too complicated. In any event, you should pause the video and try your own multiplication if it's different than mine. You should probably even pause the video and try the same multiplication if it's the same. All right, 6 times 4 is 24. Carry the 2. 7 times 4 is 28, plus 2 is 30. 0. Carry my 3. 5 times 4 is 20, plus the 3 is 23. Okay, 6 times 2 is 12. Replace by the 1. 7 times 2 is 14, plus 1 is 15. 5. Replace that by 1. 5 times 2 is 10, so I should get 11 here. Okay, 4, 2, 8, 3, 1. That's an 8 there. So we get 1 there. 1, 3, 8, 2, 4 inches cubed now. Okay, so we have a big ugly number here. Let me erase that thing right there because I don't want anybody to feel it's a number or something. All right, so so we're going to do this the same way. So if the volume of the crate, we're going to take the volume of the crate and divide it by the volume of the lotion, because now they're both in inches. So we're going to get 1, 3, 8, 2, 4, divided by 27. All right? And now we have to do division. I'm going to scroll this slightly so I can have space. I don't think we need those top words anymore. So we're going to do 27 divided into 1, 3, 8, 2, 4. So I normally prefer short division. If some of you guys prefer others, again, just the same as the multiplication, go ahead and use that. I personally find this the fastest, most efficient, least error prone, stuff like that. So just, that's my thought process, and it requires practice. Everything requires practice, no matter which kind of flavor you're taking. So 27 goes into 1, it doesn't. 27 goes into 3, it doesn't. 27 goes, into 13, it doesn't. 27 goes into 138, yeah, it goes into there. Let's see how we can do this. If it was 30, we can get 4 into there, right? 30 times 4 is 100. 20 is a little left over. So I'm going to try 5. So 7 times 5 is 35. 5, 3, 10. We get 135. Okay, so 5 went into there. 135 times. And just let me double check that. That's 100. 5 times, yep, it's 135. So we get 3 left over. Okay. Wait, that come out as a 1. That's 3 there. 27 goes into 32 one time. And we get what? 3, we get 5 left over. Okay. Uh, 3, 4, 5, right? And then 27 times 2 is 54. And that turns out to be our answer, I think. How many boxes? Yep, that's all we need to do. So we have 512 boxes of lotion. Okay. So this was about geometry again, about volume. It involved a multi-step problem here. Well, it was multi-step because we get to the volume of the cube first. In the other example, they gave it to us. So this one, we actually had to calculate it. So there was a multi-step problem there. Lots of multiplication flying over the place, and a division as well, a multi-digit division as well. So those are things that we need to be careful of. Okay, there is another way to solve this, and let me change the color of the pen. It's similar to what we did on the other problem, which again is why I wanted to spin this off to give it the extra time it deserves. So if we go back to the original volume of the crate, okay, that was 8 foot cubed. Okay, and we said the volume the volume of the lotions were 27 inches cubed. But there's an analogous way to do that. If each side was a third, that's 1/4 of a foot, right? That's 1/4 of a foot here then. And then this was 1/4 of a foot as well. So we, instead of converting these feet to inches, now we're going to convert these inches to feet instead. So this becomes 1/4 cubed. In other words, it's 1/4 times 1/4 times 1/4. So 1/4 times 1/4 is a 16th, right? And a 16th times 4, anything times 4 we can double and double. So 16 times 2 is 32. 32 times 2 is 64. So we get 1/64 feet cubed. Okay, that looks pretty weird. It almost looks wrong, but it's correct. So if we do the same thing, if we take the volume of the crate divided by the volume of the lotion, we're going to get 8 divided by 1/64. Okay, so we can write that longhand. I should have written that over here. 8 divided by 1/64. Okay, and that's the same as 8 times the reciprocal. So 64/1, or just 8 times 64. And that's all we have to do now is 64 times 8. 8 times 4 is 32. 2. Carry out 3. 6 times 8 is 48. 49, 50, 51. Okay, and we get the 512. So well, that was interesting. It turns out that this red way, the second way I'm doing this, is probably the better way to do it because we avoided this big ugly number here, this 13,824. Interesting, right? So it's kind of a little lesson there, if you will, about how to do some of this. So again, this is a lot of stuff going on these two problems, which is why it was worth spinning them off. The only thing is that cube root thing I did on the other one, maybe a grade 6, 7, or 8 question really, or approach to doing it. But hey, it's the way to do it. It's another thought. And if you're not sure about it, practice it a bit. You guys can email me. My email is always at the bottom here, GregsTutoringNYC@gmail.com. And hey, how about smashing the like button? All right, guys, have a good day, and I will contemplate what I'm going to do with the Part C to this. Peace, y'all.